Hello everyone, this is Pranava and today's video we'll be solving another challenge of MetaCTF under the category of binary exploitation. The challenge goes like, are you cool enough to get in? Connect to a command and find out. You can grab the binary here and the source code. Good luck. Let's download the binary, the source code. Yeah, okay. And they've given us the command to enter into it. Terminal. So this is basically a netcat session for me to connect into a cube node MetaCTF, basically to the address. Oh, there, my dude, only the true cools are allowed in here. What's your name? Let's try with hacker. Hacker, it look like your coolness value is 7940. I'm sorry, not just cool enough. Okay, let me try with another username or name. Okay. So I see that every time I'm trying to enter a username or a name to this particular input, I'm getting a random value that is being generated. Is it any way related to what I'm entering? For example, if I write root again, I can see that I'm getting a different output each time that I'm entering a name or a input into this field. So we need to enter the right username, I guess, to log in into or to get the flag, solve this challenge. They have provided with the binary as well as the C program or the source code in which it is written. Let's look into it now. Sublime chal.c. Yeah. Okay. The way I can zoom. So this looks like a simple C program. This is all the include statements. The program starts from here. Int your estimated coolness, char you're setting, basically you're defining the variables. One is your estimated coolness, the other one is your name is being defined with a 64-bit character limit, and then set buff stdin input and output. So basically it's making sure the stack is going to be remaining empty, and it's going to go to the stack immediately once the value is entered. Then setting the random reference to the time, see the random number generated with the current time. Okay, so basically there's a random generator which is going to be using the current time to enter or to give out the output. Printf. Okay, we have our print statement. This is what we got when we executed the command. So this is the print statement. And here comes our function, your estimated coolness. Use a standard colorness formula to determine how cool the user is. Okay, so 500. Okay, so if they're using a random function to generate a random number and it's being divided by 1000 and some mathematical operation is going on. Then comes printf. What's your name? Oh, okay. We see a gets function in here. So the gets function by nature, in situations where you have set limited characters in the stack, it's usually vulnerable to it, and I don't see any filtration going on here. For example, the gets function in C is going to receive the input from the user till it has an end of file argument given in the code or given by the user. So by nature, in such environment, it is naturally vulnerable to attacks such as buffer overflow or stack-based overflow attacks. We can look into an example of this. For example, let's write a very simple C code in here, which is going to have a gets function in it. Let's import, I mean, the include stdio.h, then our int main. Yeah. Okay, let me define a character called bug with a stack limit, maybe say up to 5. Then let's also, okay, let's add just a flag integer with some values 1, 2, 3. Let me do the space. Yeah. So I'm going to print f, enter message. Okay, then let me use the get function. Gets the bug. It's going to upload the input whatever the user is going to be giving or the entering, and it's going to assign it to the bug variable, which has a stack limit of 5. I'll explain what am I doing in a minute. So printf, I'm going to print the message, the entered value, the percentage s, which is string. Let's go to new line. That is bug. Then let's also printf. Let's also print the string that we have taken, percentage %d, if I'm not wrong. That is flag. Yeah. Then it is int main return the 0 which says success. Okay. So saved in downloads itself. Test.c. Okay, so I've written a basic simple C program which has a stack limit of bug 5, and then I've also as soon as I enter the I've assigned the bug variable. I've also assigned another variable called flag, which has an input or which has a value in it called 1, 2, 3. So what happens is whenever we work with variable environments, the variables are going to be assigned to the stack of the computer or the hardware. So a stack is going to be having a logic sequence of first in last out, and that is going to be storing the input or the variables, and it's going to have the value stored inside it. For example, for the bug variable which I have assigned, it's going to give a stack limit of 5 characters. So anything beyond the character 5 or bits, 5 bits, it's going to be overflowing or it's going to be consuming more space than what is allotted for. What happens in the gets function is that the gets by default does not have this function or any check mechanism for counting the number of stack size which is being allocated by the program versus what the user or the input is being given to the program. So by nature, this makes the program vulnerable to attacks like buffer overflow, which is going to overflow the original stack limit to the next variables which are stored in the stack. So it's going to corrupt the memory of it. Let's take an example. For example, if I'm going to compile this, I have the file here, right? Test. So gcc test.c and output, let me name it as test itself. I naturally get this warning sign from the compiler telling that the gets function by default is vulnerable or not to be used, and since it is by nature it's dangerous. What will happen if I run the program, right? Let's try that. Test, enter a message. Since I've given the stack limit to be 5, and if I enter this just the one bit which is less than the stack limit, I'm going to get the value which is a and 1, 2, 3. What is going to happen if I'm going to enter more than just one character? That is, if I randomly set so much of characters, I'm going to get some errors, right? You can see this. And you can also see that the value of 1, 2, 3 is corrupted by the values of A. So there's some hexadecimal characters of A which is converted for the stack memory, and it's overflowing into the variable which is assigned for my flag variable, which was initially meant to be 1, 2, 3. Now it has been overflown by the message which I gave AAA. So you can see I can see the vulnerability in my the program which they have given. Did I edit it? Okay, no. Okay, so we can try to overflow our input from this. Let's try with what's going to happen if I enter a huge value into this input field. Just a random huge stack value. I'm going to press enter. I'm sorry, you're not just cool enough. Get lost. Okay, so even this huge, maybe the stack limit of it might be set huge. It's just 64 characters, right? Yeah. So If I even have to overflow, I just need to enter characters more than 64. So that's fine. But how is this evaluating my coolness? So it's going to print out the string, which is your name, and then it looks like a coolness value, an integer, which is okay. That is this algorithm using the random function. Then it's using a if condition to check if our estimated coolness is less than this value. Okay, if it is, then okay, it's not going to be printing out the flag. If it's greater than this value, okay, it's still not going to print. Okay, and if the value is equal to exactly this number, then we are going to be getting the flag, and it's in get env, which is in the environment. So okay, so that's this algorithm of your estimated coolness using a random function. If I know it right by the random function, I'm not sure if this is mathematically even possible to get the such huge value with these conditions where I'm just adding up 500 plus 10 and then multiplying with some decimal value. So not sure if I'm going to be having such huge number for any of the values of random. So this is an impossible event which is going to happen from your estimated coolness function. So the only way that I can think of now is to overflow my character, which where I'll be inputting, where I'll be input to the function, so that it overflows into the stack memory of your estimated coolness, and then it's going to match this value, right? So okay, so let's first look at what is the hexadecimal character. Since this is going to be going into the stack memory of the computer, we need to convert this bit of this number into a hexadecimal value. For that, let's also look at the architecture that this is compiled in. For the chal, the file chal, this is an 64-bit and x86 4-bit version. Okay, okay. So, so the challenge is that we need to make sure that the input what we are giving is going to be having more than 64-bit characters in it, and is going to also overflow in such a way that the hex value of this number is going to be overflowed into the variable your estimated coolness. Okay, and we should also make sure that it is with the x86, because the compilers use, there are different types of compilers where it gives uh, what importance to the least significant bits and major significant bits. So I guess this is Little Indian format what 86 bit follows. What format of um what format of that term, what format of processing is used in x86? I guess it's little. hmm, I guess it's right. Okay, so yes, it uses the Little Indian. So this is going to give the preference to the least significant bit to the major significant bit architecture, or the code, or the values what we are going to be entering in the hexadecimal format. So let's calculate for the hexadecimal. Yeah. Okay, so let's enter this value into calculator. Then calculate for the value of this hexadecimal. Okay, so we get this output of the hexadecimal value, which is going to be read by the memory in the way how it is. And because we need to make sure that the least significant bits come first and then the major significant bits appear. So we need to start entering the values in 2 bits from the right to left. let's even convert this into the way we want it. Okay, so now we are not sure of what number of values is going to be overflowing our stack, right? When we have a stack with the variables first put in by the input what we're going to be giving, and then it's going to be the variable of the coolness, or the one which the integer is going to be comparing into. We need to find the right number of bits what we need to be overflowing into the stack memory, so that even this hexadecimal value is going to stay, or is going to be completely filling it in the right format on how we need it to be overflowing it. So we can write a Python script basically to um, exploit.py. Let's write a Python script to brute force this particular mechanism of getting our exploit or overflowing our stack memory. So we have a executable file chal. So I'm going to try and execute it and see what's wrong with this file chal. Okay, maybe the privileges are not given. Chmod plus. So now I'll be able to run the tool, right? Yeah, some random value. Yeah. So we will use this program which is given by the MetaCTF, and then try to write a Python script for exploiting this or overflowing the buffer with it. First thing, let's mention our shebang user bin Python 3. I guess that's what we are using. Which Python? Yeah. Let's import OS, then import a sub process. We'll be using sub process for running commands inside it. So for I in range, let's give from 60. I know, I mean, the minimum value is going to be 64, obviously, but let's give from 60 to, let's say, 100. Um, then make a payload, which is going to be the input that we'll be entering in. Let's go with A's, and this times A is going to be repeated times the number what is going to be in the range, which is initially 60 up to 100. Plus, also let's input our hexadecimal values into it. Yeah, first we need to make sure that this is in the format how the stack is going to be reading it. So slash x01 slash x2f slash x 68 slash pi9. Okay, so this is going to be our it's going to be from the least significant bit to the major significant bit of our code, which is going to be overflowing the exact value what we need. It's right here, right? So the exact value that we need into the stack of this. So our payload is ready now. Okay, how do I exactly look into it, right? I mean, how do I get the flag out of it for just for the purpose of test? We see that they're getting the flag basically from the environment, and they've named it as flag itself, right? So let's also set our OS environment to have this um, environ, then flag. That's what they've used, right? Yeah, flag equal to test flag. Process is equal to sub process dot p open, and then the brackets. Let me mention the file which is in the same directory. I've opened the same directory, right? Yeah, the exploit is opened in the same directory. Let me zoom in. Yeah, Charles, that's the program name. Yeah, then the input that we'll be giving into the program is standard input sub process dot pipe. Then standard output is going to be std out is going again subprocess dot pipe. Then standard error if I get in case any error. So that's going to be subprocess dot pipe. Yeah. Let's make sure that the standard output and the standard error is going to process dot communicate input is equal to payload. Okay, so yeah, so now I wanted to print the standard output. What is that? Yeah, this should do the work. So I have the file here, python 3 exploit.py. Oh, okay. I've added a semicolon now. Hmm. Okay. Environ. Oh, okay. We get so basically this is running the code, and we see the number of A's increasing, but this is a lot messy, right? Let's we see a new line character. Hmm. Okay, okay. In one of the outputs, what I've even got are I've even overflown the stack. As of now, I'm not able to see anything. So let's make it in a good format. Let me add this function dot decode if I'm right. I don't know if this will work. We might have to Google this. Okay, right. Yeah, I see it. Okay, so a value is this. I don't see any specific value which is saying that yes, I have got the, or I don't even know what is my the right results output, right? Oh no, it's here. Okay. What's wrong with it? Looks like use it. Just increase. I guess I saw it here somewhere. Oh no. Okay, so let's run this code again. Q value is this. Okay. Now this looks quite neat, right? So okay. Now I actually don't see any output which okay, let's do this and then grep to get our flag. So test flag, right? Yeah. Oh right, here's the flag. So let's copy this. So but what value of this A did it actually overflow, right? So okay, let's also print uh, print I. What's I guess something is wrong. Okay, I don't need no, I need this. Wait, so every time I use a grep, I'm just going to be getting this, no? So let me add this function then. If it is saying this one, if it's saying this output, then in std output, okay, then print I. Also the print this. If not, I don't need. Okay, so basically, I'm filtering out what I need from the output, what I'm expecting. So I don't need this. Yeah. So the 76th value, I mean, after 76 times of repeating this character A, and then also incrementing this or adding this bits of hexadecimal character of the flag, we are getting this to be overflown and the flag is right. So this would, if we run the same program in the netcat session, we'll be getting the flag. So we know that we need to enter this for 76 times to get the flag right. Okay. So now we can exploit this using Python C. I have already written this command up here. So what this is doing is importing sys, then same the values whatever we have. In this case, I've used Z instead of character A, which does not matter to us, and then I've added this end bit of it. Pass this entire output into the command of net session, and here we see that we have successfully overflown the stack of the environment and have got the flag from it. So this was quite a pretty easy challenge after we had the source code of it. If not, we could have disassembled this program, what we had in using GDB, and then would have understood how the program works. So this is quite a simple challenge, and we had a gets vulnerability in it. Or I don't say it's a vulnerability; it's basically a function where the end of file is required. It's going to be running it till the end of file is received from it, which naturally is vulnerable when you have a set of limited stack assigned to it. So hope you learned something from it. Thank you.